Hi class. One of the things I like about this class, obviously I'm a nerd and it's, weather's been my life pretty much for the last 60 years. But one of the things I really enjoy is how all the concepts come together. And so this is one of those instances. If we look at changes in weather after a front passes, we can put together a lot of the concepts that we've been learning over the entire semester into this one picture. Okay, so let's start off with a low pressure that we've drawn a number of times. So here's a big red L that you'll see on a weather map. And we know that the airflow around a low pressure is counterclockwise and inward. So we can draw that in. Okay, this is nothing new again. We've seen this before. Okay, now let's draw in, typically with a low pressure, we'll have a warm front that extends out similar to this. Okay, and let's put in a cold front that will often flow off toward the southeast like this. So blue line with blue triangles. Now what we're going to do is we're going to draw in weather station models in the various areas around this low pressure and see how weather changes as you have the passage of a warm front or a cold front. So if we have a weather station model to the north ahead of a warm front, notice that the wind direction is typically going to be easterly. Okay, and we'll just make that 10 miles per hour. And I'm going to put in a representative temperature and dew point. So temperature might be maybe 68 degrees and a dew point of perhaps maybe 59. We'll do it that way. Okay. And now this is going to be, we can kind of draw this in 3 dimensions if you wanted to. So remember, this is going to look kind of like this. This is the wedge of continental polar air that is retreating. Okay. Now, if we have another weather station model here in this portion of our map, okay, this is going to be the maritime tropical air. Okay. And I suppose I should have made that in red. Our maritime tropical air. And so this is warm, moist air. So perhaps our temperature, well, let's do the winds first. The wind is going to be out of the south. We'll just make it 15 miles per hour, 15 knots more specifically. And the temperature might be 81 degrees. And the dew point is 72. So notice that as this warm front is moving towards the north, okay, what's going to happen to the weather at this weather station? It's going to get warmer, okay, as currently it's in continental polar air. When this warm front moves towards the north, it will eventually be under the influence of maritime tropical air, so the temperature is going to increase, okay. The dew point is going to increase because it's maritime air. It's going to get more humid, so the dew point temperatures are going to increase, and the wind is going to change direction from an easterly component to a southerly component. So once again, temperatures, when a warm front passes your location, temperatures are going to increase. The air is going to get more humid, as represented by an increase in the dew point temperature, and winds are going to shift from an easterly component to a southerly component. All right, now let's take a look on the other side of the cold front. Okay, over here, we'll put in a weather station model, and notice the direction of the wind is going to be out of the west, maybe northwest. We'll make this a 20 knot wind, and notice the again, you're going to have, this is going to be continental polar air. So if we make it 3 dimensions, like this will be continental polar air, colder, drier air, and the temperature at this weather station model because the cold front has already passed by, the temperature is going to be cooler. I'll just throw in 64 degrees. So you've had a temperature drop of 17 degrees, and perhaps the dew point temperature is 49 degrees. Okay, so once a cold front passes by your area, notice that your temperature is going to get colder. Okay, your dew point temperature is going to get colder. The dew point temperature is going to drop. The air is going to get less humid. It all makes sense because it's continental polar air, colder, drier air. Once that front passes by your location, you're going to get colder and drier. All right, so in this particular case, in our example here, the temperature dropped by 17 degrees. The dew point temperature dropped by, 23 degrees. So that's a pretty good drop in temperature. So if you can picture all of these things going on at once and kind of picture them in 3 dimensions, I think it really helps your understanding of the concepts. And so how does weather change after a front passes? Just take a look at what type of air mass you're under, okay, and that'll give you a sense for what your temperature and dew points are going to be. See where you are in relation to the low pressure, where the direction of the winds will help with that, and then notice how your temperature, dew point temperature, and winds all change with the passing of frontal boundaries. Alrighty, so I hope that helps. If you have questions, make sure you're contacting me. Alrighty, take care.